So for to conclude this packet, we have questions from 34 to 41. So let's complete this one, and then we can attempt the second packet that you had. So for number 34, they want to know how many moles of oxygens are in that many moles of calcium nitrate. So what you need to do, first of all, is to see that if you have that many moles of calcium nitrate, you got to find out how many moles of oxygen you have, right? So that's what the question is asking. But for every one, right, for every 1 mole of calcium nitrate, you have 6 moles of oxygen. So for every 1 calcium, you have a ratio 1 calcium to 6 oxygens. That's what I wrote here, what this means. So if that's the ratio 1 calcium to 6 oxygens, how is the ratio, since the ratio has to be maintained, how much oxygen you need to have in order to maintain the ratio with 1.08 moles of calcium instead. So basically, that's just the ratio that you put in place, right? You just cross multiply and you find out that you need 6.48 moles of oxygen. So your answer C is the right answer. Number 35. How many grams of calcium nitrate? Calcium nitrate contains contains 24 grams of oxygen atoms. So we know how many oxygens you have. So how are you going to write this? Well, so you have 24 grams of oxygen atoms, right? So then you need to keep in mind which one is the formula that you have. So you have calcium nitrate is over here. So first thing you need to do when you're looking at your calcium nitrate, when you look at a formula, right? This means you're looking at 1 mole of it. So you're looking at moles. So for every 1 mole of calcium, just like before, right, you have 6 moles of oxygens. But you got to go backward instead. So how many moles of oxygens you have? Well, you know that 1 mole of oxygen is 16 grams, right? So at this point, by doing this ratio, because those are grams per mole, so you can put it like that if you wish, right? So this one, let's leave it aside because that's your formula. So the number that you get in this case is, I don't know, so 24 divided by 16 is 1.5. So 1.5 moles is what you have for your oxygen. So moles of oxygens. So again, your ratio says 1 calcium nitrate, right, is connected to or wants 6 oxygens, right? So you have instead 1.5 moles of oxygen. So how much calcium nitrate you need? So it is going to be 1.5 divided by 6, which is 0.25. What did I just say? So 0.25 are the moles of calcium nitrate. They want to know how many grams, so your job is to convert this one into grams. So 0.25, let me change page, 0.25 moles of oxygen, right? How many grams? No, this is the calcium nitrate. I'm not sure we have it. So 0.25 moles. Those are the calcium nitrate because that's your X, right? Calcium nitrate. Okay, so how many grams are there? So you need to have 1 mole here and the grams over there. And the grams are 164 because you have 1 calcium, 2 nitrogens, and 6 oxygens. And this is going to be 41 grams is your answer. So answer E is going to be the right answer for this test. Okay. Then for numbers of 41 grams, we're right there. So 36, for problem 36, how many molecules of methane are contained in 48.2 grams of this compound? Well, that's really simple. So you have your methane, so CH4, and how many molecules of this? So you want to go to molecules at the end, and you're starting with 48.2 grams methane. So you got to go to moles first. So this is 12 plus 4 is 16 grams is 1 mole of methane, the weight, right? And then you know that 1 mole contains 6.022 10 to the 23rd molecules, which gives you an answer of 1.81 times 10 to the 24th, and this is your answer D. Then for number 37, they want to know what is the number of moles. So let's see. What number of moles of O2 is needed to produce this many grams of P4O10 from P in a synthesis reaction where you have 1 mole of P4O10 is produced for every 5 moles of O2. So you have already, and they give you the mass also. So you have already your ratio in place. So you have 1 mole for 5 moles of oxygen. So how many moles of this? 2x moles of oxygen, and your problems are solved. So let's do it. So 1 mole of P4O10 is produced for every 5 moles over 2. Now you know that you have 14.2 grams, which you got to convert to moles, right? So you got to divide by the molar mass that they are giving you, 284 grams per moles, right? Divided by x, and your x is going to be 0.05 moles of P4O10. And your answer is D again. Then for 38, they say, which of the following gas sample contains the greatest mass of gas molecule? So in every 1 liter, the number of moles is the same, but every mole has a different mass. So obviously the greatest mass is the xenon because it's below the periodic table way down. So B is going to be your answer. 39, they say the molarity of the, so they want the molarity. They give you grams, which of course you got to convert to moles. You divide by the liters and you have molarity in place. So let's do it just to make sure that we know it. So you have 75.3 grams of glucose, and we found already that the mass was 180, so you can just divide by 180 grams. This is 1 mole. So this will give you a mole of 0.418. So at that point, molarity is going to be equal to the many moles divided by the liters, which are 35.5 milliliters, which means times 10 to the negative 3 liters, and this is 11.8 moles per liters, which is your molarity. So answer E is going to be the choice. Then number 40, how many milliliters of, so let's see this, how many milliliters of this concentration of sodium hydroxide solution contain 25 grams of sodium hydroxide. So you have molarity, which means you have moles per liter. You got grams, which obviously you got to convert to moles, and then you can just solve for the liters. So let's do it. So you have 0.123. Those are your moles per liter. And this is the same as the moles that are contained in 225 grams, which you got to convert to moles. So you divide by 40 grams per moles, divided by the volume, which is what you're solving for. So you have 0.123 moles per liter equal to 0.625 is this number here, divided by the volume. So your volume is going to be equal to 0.81 milliliters. So you will have your answer from here in liters, but then you got to convert it to milliliters anyway. And the last one, what is the total concentration of ions in a solution of sodium carbonate? So for this one, what you do, so first of all, you will take your sodium carbonate and you put it in water. So your aqueous solution will produce 2 ions of sodium, right? And 1 ion of carbonate. So for every 1 mole, right, you have a ratio of 3 ions of moles, right? So at this point, what you do is you have ratio of, for every 1 mole of sodium carbonate, you have 3 ions, but they give you 0.036 moles of sodium carbonate. So what is the moles of ions at this point, the concentration of ions at this point? So you solve, and this is 0.108 concentration of ions. Which is your choice? B. And we're done with this.